Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
Divisibility rules in maths. This is important for your non-calculator questions. There are usually two sections, calculator and non-calculator. Have you started doing answering questions like that? Well, from this level, you will be from this level you will be exposed to two components of maths: the calculator part and the non-calculator part. So you really need to understand some of these divisibility rules. Some of them I believe you should be familiar with. For instance, how can you tell that the number is divisible by 2? Just read it out. Go ahead. How can you tell a number is divisible by 2? Go ahead and read it out. I hope you can see what I'm sharing. Go ahead. Let's work faster.
If the last number is 1,
If the last
3,
if the last number is even.
by 3.
Okay, first of all, I'm talking about 2. How do you tell if a number is divisible by 2? If the last number is even. Can you give an example? Can you give an example quickly? Or let's give some examples. Yes.
32. 2 is even, so
32, 0, 10, 64.
32.
I've written,
2.
I've written 32, 10, 64, etc. Okay, what about, how do you tell a number is divisible by 3?
9.
You need to read the rule. If the sum of the digits is divisible by 3. Do you know what that means? If you add up the digits,
Sum of the digits is divisible by 3.
like if you add up the digits, if it is divisible by 3, example, if you have 4, 3, 2, add up 4, 3, 2. 4 plus 3 plus 2, add up the digits.
Yeah.
4 plus 3 plus 2 is 9, and 9 is divisible
Right.
by 3, so it is divisible by.
It's 39. 3 plus 9 is 12.
Okay.
And that's divisible by.
Give me another example. Give me another example. Give me an example. You need to work faster because we have a lot of questions we're going to answer. And you need, I need another example quickly. Can I have another example quickly? I'm waiting.
42.
42. Please, you really need to be.
42.
Yeah, you need to be responding faster. All right, 42 because 4 plus 2 will give you 6, and 6 is divisible by 3. Okay, number 4, divisible by 4 or divisibility by 4. By the way, divisibility means you can divide without a remainder. A number is divisible if it can be divided evenly without a remainder, that's with no remainder. So divisibility by 4, if the last two digits is a number divisible by 4. So can we have examples? The last two digits. So for instance, 8, 5, 7, 3, 2. Do you know that 8, 5, 7, 3, 2 is divisible by 4? And why?
Yup.
Because
32 is divisible by 4.
because 32
And 4, you can put 4 in 100. So, like,
yeah.
the last two digits that matter.
All right. Number 5. If the last number is 0 or 5, it is divisible by 5. Actually, that one is easy enough. Like 50, 45, and so on. Number 6, quickly, if the number is divisible by 2 and 3, so can you give me examples? A large number, okay.
The number ends with like 5 or 0.
No, I'm talking about number 6, divisible by 6 now. Divisible by 6 now.
Oh,
If the number
okay.
is,
The way we write it is if
yes, if it is, what?
the number is divisible by 3. So like 12. 12 is divisible by 2 and divisible by 3.
Okay. If it's divisible by 2 and divisible by 3, like 12, like 24, like, and so on. Once it is divisible by 2 and divisible by 3, okay, well, some of them are not that's common, so we just, like, if it is if for 7, if you double the last digit, subtract it from the rest of the number, and that number is divisible by 7. Don't bother about this one, it's not really a common thing. Look at 8. If the last 3 digits are divisible by 8. Did you get that?
Yeah.
Last 3 digits are divisible by 8. If the last 3 digits are divisible by 8. If you have, example, 463,096. What is 8 times 11? 8 times 10 is 88, plus 80,
88.
88, okay. Do you know that this is divisible by 8? If the last 3 digits are divisible by 8, you know,
Yeah, no, but like if the last 3 digits, then that's just hard.
the last 3 digits. What is 8 times 12? Let me give you another example. 8 times 12 is 96. 8 times 13 is what? 8 times 10 is 80. 8 times, if you add,
104.
I mean 8 times 13. Is that 104?
Yep.
8 times 10 is 80. 8 times 11, 88. 8 times 12, 96. 8 times 13, 104. So if you have something like this, 463104 is divisible by 8 because the last 3 digits is divisible by 8. Okay, divisibility by 9, if the sum of the digits is 9 or divisible by 9, you know, if you add up the digits, if it is 9 or if it is divisible by 9, you know, it is, for instance,
Or like 90.
513. Do you know 513 is divisible by 9? Because if you add up the digits,
Yes.
5 plus 1 plus 3 will give you 9. Okay, 10 is easy. If the number ends in 0, like 100, 10, 50, 60, so and so on, that one is easy. Now, this 11 is not a common one, but you need to know it. Read it out. Divisibility by 11. Please read it out quickly.
10.
I'm talking about 11. Please
11.
concentrate. You need to concentrate so that you can follow through.
If
Go ahead.
alternating sum of the digits in the number, read from left to right. That is divisible. If that's divisible by 11, then it shows the original number.
Okay, if you take the alternating sum of the digits in the number read from left to right, if that is divisible by 11, so is the original number. What do we mean by alternating sum? Alternating sum means you add, you subtract, you add, you subtract. Let me give you an example. Look at this. 4, 3. Oh, no. I'm writing a number. I'm not supposed to I put a comma. 4, 3, 6. 4 plus 3 is what? Also 4 minus 3, starting from negative. 4 minus 3 is what? I need you to do this sum. 4 minus 3 is what?
1.
Plus 6. I have
7.
an example. Let me bring up this example. 32516. Let me use that one. 32516. 32516. 32516. 32516. This is how we know if it is divisible by 11. Find the alternating sum. The alternating sum is alternate between plus and minus. For instance, 3 minus 2, 1 plus 5, 6 minus 1, and so on. Let's go.
12.
Are you sure it's up to 12? Let's do the alternating sum, starting from minus.
Oh, 3 plus 2 is
No, 3 minus 2
1, 6, 5,
plus 5,
11.
then minus 1, then plus 6.
That's 11.
If it is whatever you get, if it is divisible by 11, then the number itself is divisible by 11. In fact, anything you get if it is a product of 11, and that includes 0 or even minus 11. I will give you another example on this. First of all, let's take more examples on this. For instance, when we always start with minus. 3 minus 2, that's 1, plus 5, that's 6, minus 1, that's 5, plus 6, that's 11. Okay, look at another example. Are you ready? Let's see this one. 5, 5, 4, 5, 4, 5 minus 4 is 1, 3, 5 minus 4 is 1, plus 3, then 2, 5 minus 4, 1, plus 3, 4, minus 2, 2, plus 2. Can we do this one? Let's go. 5 minus 4 is 1, plus 3. Okay, let me write it down here. 5 minus 4, plus 3, minus 2, plus 2. 5 minus 4 is 1. 1 plus 3. 1 plus 3 is 4. 4 minus 2 is 2. Okay. No. Let me put 0 here instead. 5 minus 4 is 1. 1 plus 3 is 4. 4 minus 2 is 2. Okay. 2 is not complete. Let me put 9. I want something that will end in 0. I want something that will end in 0. Let me adjust that number so that you get the point I'm making. 5 minus 4 is 1. 1 plus 3 is 4. 4 minus 2. Okay, why not just write 4 here? Let it end in 4. Let it end in 4. Let me end it in 4. So 5 minus 4 is 1. 1 plus 3 is 4. 4 minus 5. Okay. Minus
That's
4.
0.
That's 0. Okay. So it's divisible by 11. Once it ends,
0 is divisible by 11. What?
yes, it is. Let's say 5 minus 4 is 1. 1 plus 3 is 4. 4 minus 4
I thought
is 0.
0 was only divisible by like.
No, 0 is a product of 11. Because 11 times 0 is 0. This gives 0. 0, 11, even minus 11, even 22, even minus 22, they are all products of 11. So if it gives all these numbers, they are divisible. Why is 0 a product of 11? Because 11 times 0 is 0. And of course, this one is 11.
Oh,
Yes.
okay.
If you like, you can check this out. 5434 is divisible by 11. All right. And for 12, if the number is divisible by 3 and 4, it is divisible by 12. You know, there are many examples. Once the number can be divided by 3 and divided by 4, it's divisible by 12. Okay, this is what I want you to do very quickly. Are you ready? Are you ready?
Yep. Yeah.
Okay, these are some of the further explanations. Divisible by 2, a number is divisible by 2 if the digits at once, that is the units, is even. Like 100, 122, and so on. 1658. Divisible by 3 if the sum of the digits is divisible by 3. Like 27648. If you add them, it's divisible by 3. Adding it gives 27. And divisible by 4 if the last two digits is divisible by 4. Like 1124. 24 is divisible by 4. Okay. Divisible by 5 if it ends in 0 or 5. Like 225, 605, 100, 9925, and so on. Divisible by 9 if the sum of its digits is divisible by 9. Like 16911. If you add up 16911 is divisible by 9 because when you add up it gives 18, and 18 is divisible by 9. Divisible by 10 if it ends in 0 is divisible by 10, and so on. And the other one I talked about. Okay, let's quickly go through this. Let's go through the practice questions. Which of the following numbers are divisible by 2, 5, or 8? Let's go. So the one that is by 2 you say, 5 you say, 8 you say. So, sorry, 2, 5, or 10. No, divisible by 2, 5, and 10 all together.
Oh, so me personally, I think it's 2, the second one,
19400.
and IV, and then V.
This and this. Okay, this will not. This will not. Okay. Check whether the numbers are divisible by 4. Divisible. Okay, by 4. The last two digits should be divisible by 4. So let's go. Let's run through it very quickly.
I is divisible by 4.
Because 8 is divisible by 4.
That one is divisible by 4.
It's not.
Yeah.
This one
It's divisible by 4.
is divisible by 4. This one.
Not divisible by 4.
This one. Of course.
Divisible by 4.
Is this one divisible by 4?
Yeah.
This one.
Not divisible by 4.
This one.
And then the last one is divisible by 4.
Okay. Let's see this one. In each of the following numbers, without doing actual division, determine whether the first number is divisible by the second number. Whether this is divisible by 6. Whether this is divisible by 6, and so on. You know, for it to be divisible by 6, it must be divisible by 2 and 3. Let's add up. 3 plus 4, 7, plus 0, 1. 7 plus 9, 15. Sorry, 3 plus 4, 7, plus 0, 7 plus 9, 16, plus 1, 17, 19, 21. 21 is divisible by 3, and it's also this number, the last digit is an even. So what I'm saying is the sum of digits, which is 21, is divisible by 3. You know what I mean? It's divisible by 3, and the number itself is even, so it is divisible by 6. Do you agree with me? Let's look at the second one. Do you agree with me? Because for a number to be divisible by 6,
Oh yeah, yeah, yeah.
for a number to be divisible by 6, it must be divisible by 2 and 3. Let's check this one. 17218. First of all, it's divisible by 2 because it's even. But let's see if it is divisible by 6. By 3. Let's add the digits. 1 plus 7, 8 plus 2, 10 plus 1, 11 plus 8,
And then 19.
19. And 19 is not divisible by 3. So why it is divisible by 2, it is not divisible by 3. So this one can't work. You know what I mean?
Yeah.
Because for it to be divisible by 6, it must be divisible by both 2 and 3. 19 is not the sum of digits. It's equal to 19, which is not divisible by 3. By 3. Okay, and so on. Do you know the rule for divisibility by 8? Can we remind ourselves again? The last 3 digits must be divisible by 8. The last 3 digits. The last 3 digits. Is 712 divisible by 8? You can check. Obviously, 804. Is it divisible by 8? If it,
4 isn't, but like.
but is 804 divisible by 4? You know, it's
Oh yeah, yeah, yeah.
the last 2 digits. If the last 2 digits is divisible by 4. So this is okay, and so on. Let me see if there's any other one. Say 6 is a factor of this and this. Is 6 a factor of this and this? 6 is a factor of this and this. Is 6 a factor of this plus this and this minus this? Can we check? Let's check the plus. 49320 plus 12066. This is 6, this is 8, this is 3, this is 1, this is 6. Sum of the digits. 6 plus 1, 7, plus 3, 10, plus 8, 18, plus 6, 24. Sum of digits, let's just do 1, is 24. And 24 is divisible by 3. And of course, the sum 61386 is also divisible by 2. So this is divisible by 6. This is correct. This may not be. You can check the minus later. Are you following?
Yeah.
What I'm asking you, you can try the difference to know if the difference is divisible by 6. You know, you can check that. 4 9 320 12066 and subtract. This is 6 This is 5. This is 2. And this is 7. This is 3. Sum 3 plus 7, 10, 12, 17, 23. No, this one is not divisible by 6. Sum is 23. 3 plus 7, 10 plus 2, 12, 17, 23. 23 not divisible. Divisible by 3. So it's not divisible by 6. So this is not. Or rather, this is not. Okay. You can do all of these ones. For instance, look at this one. II. It says fill in the smallest digits to make the number divisible by 3, for instance. 1 what 43 will be divisible by 3. Tell me. Let me zoom it in. Tell me. What must be here to make it divisible by 3 for each of them?
God. 1.
Okay, because already the sum must be divisible by 3. 1 plus 4 is 5, plus 3
Yeah,
is
that's why I said
8.
1.
So 1 is correct. What about this one? Of course, this one we can write 5 or 0. Anyone will be divisible by 5. Once it ends.
2.
Okay, 4 plus 7 is 9. 9 plus 5 is 15. 4 plus 7 is 9. 9 plus 5 is 14. Are you sure? Oh, sorry. 4 plus
7
is
is 11.
11. Sorry, 4 plus 7 is 11. 11 plus 5 is 16. So 16 plus 2. Okay, 2. And so on. This one is 3 plus 1 is 4. 6. So maybe 2 here. Right? Or even 8. You can use 2 or 8 here. Because 8, 3, 1, 6. If you add up, 8 plus 3 is 11. 11 plus 1 is 12. 12 plus 6 is 18. This one, no go. 2 plus 3 is 5 plus 1. 6 plus 6 is 12. So, and so on. This one is about the last 2 digits. If we put 4 here, it's divisible. If we put 2 here, it's divisible. So long as the last 2 digits is divisible by 4. You know what I mean?
Yeah.
Oh, sorry. This one has 2 digits. So we might put like something like 3, 2. This one has 2 numbers. We might put something like 32. This one is already 670. You can put something like 8. Do you understand?
Yeah.
All right. And so on and so forth. So it's not a big deal. It's the same thing. Like this, what's this question saying? This one, you can just practice using the divisible rules. Check whether the number is divisible by the given numbers. Put P for a tick and U for a cross. It's not a big deal. Whether it is divisible by 2, of course, this is, we can put P. We can put U, we cannot. That's concerning 10. We can put U, we can put P. We can put U, we can put P. Because 10 can divide 10. For 2, we can put U, we can put P. We can put U, we can put U, we can put P. Because 27 can divide 9, we can put U. And so on. You can do all that. Am I right?
Yeah.
Okay. I think it's the same thing. Check the divisibility rules, filling yes or no. You know, that's the same principle. For instance, 144. Is it divisible by 3? 1 plus 4 is 5. So we can actually put a yes here. Because 1 plus 4 is 5 plus 4 is 9. And then you fill the rest just for your practice question. So which of the two nearest numbers to, can you do number 9 very quickly? Which of the two nearest numbers to 19506 are divisible by 9? How do we know if the sum is divisible by 9? 1 plus 9 plus 5 plus 0 plus 6 will give us 10, 15, 16. So if we just add additional 2, if we add additional 2, do you understand? So it means 195,062 will be divisible by 9 because 1 plus 9 is 10 plus 5, 15.
What?
Yeah, 1 plus 9 is 10 plus 5, 15.
No, that's not right. It's
Oh, that's not right. You're right. I made a mistake.
1.8.
I made a mistake. Okay, 1 plus 9 is 10 plus 5, 15 plus 6. Plus 6 is 21. 21. 21. So what do we need to add?
Make it divisible by 9. You need to add
8, yes. No, 6. We just add 6 so that it will become 27.
yeah.
So another 6. 10, 15, 21, yeah. All right, so that's it. Choose the right answer. The number with units digit 05 is divisible by 05 is divisible by 5. The number with the digit 02468 is divisible by 2. You know that the number with units 0 is divisible by 10 and 2.
Yeah, and 5 too.
And 5 2, you are right. 3681 is divisible by, this is 9 plus 9, so it's divisible by 9. It's divisible by 9 because the sum is 18. All right, and so on and so forth. I think you can practice the rest. Say multiple choice. Which of the following number is used by 2? Is the same principle. It's the same principle. It's the same principle. It's the same principle. You just practice the rest. You can see it.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.